What is nothing? It sounds like a simple question. A child could answer it. Nothing is an empty box. Nothing is a room with no furniture. Nothing is the dark space between the stars. But if you ask a physicist to show you true, absolute nothingness, they will tell you it might be the most complicated thing in the universe. In fact, trying to find it might just break physics entirely. Think about the air around you. If we took a massive pump and sucked every single atom out of a sealed room, you would have a perfect vacuum. No oxygen, no dust, no matter. Most people would look at that room and say there is nothing inside, but they would be wrong. Even if you remove every physical object, you cannot remove space itself. Space has geometry. It can bend, twist and ripple with gravitational waves. And hidden inside that space are invisible forces, magnetic fields, gravitational fields and the Higgs field, which gives everything mass. So, if the space itself is still there and the invisible fields are still there, you haven't actually created nothing. You've just cleared the stage, but the stage itself is very much alive. For thousands of years, humans didn't need a complex scientific equation to understand emptiness. To our ancestors, nothingness was a simple concept, the absence of stuff. If you look into your wallet and see no cash, you say you have nothing. If you look at a blank piece of paper, there is nothing written on it. But early philosophers quickly realized that our everyday definition is a trap. The ancient thinkers argued that you cannot even think about true nothingness, because the moment you think about it, it becomes a concept, it becomes something. For centuries, humanity has struggled with this paradox. We created the number 0 in mathematics to represent it. But in the physical world, creating a space where absolutely nothing exists turned out to be an impossible engineering challenge. Our human brains are wired to see the lack of objects as emptiness, but nature refuses to cooperate with our intuition. Let's look up. Deep space is the closest thing to nothingness that humans can easily imagine. Millions of light years away from any galaxy, in the deep void between clusters of stars, it is incredibly cold and dark. Surely, this must be it. This must be the ultimate nothing. But it isn't. Outer space is absolutely flooded with activity. It is constantly bathed in the cosmic microwave background, the faded leftover radiation from the Big Bang itself. Photons or particles of light are streaming through that space from stars billions of light years away. Cosmic rays, dark matter, and neutrinos pass right through the void every single second. If you sat in the deepest, darkest corner of the universe, billions of invisible particles would still be raining down on you. Space is not an empty canvas. It is a crowded highway of ancient energy. But it gets stranger. Let's zoom in. Past the atoms, past the subatomic particles, down to the absolute smallest scale of reality, the quantum realm. Imagine we could somehow shield a patch of space from all radiation, all cosmic rays, and all fields. A pristine, quiet vacuum. What happens if you look at it? It is screaming with life. According to quantum mechanics, the fabric of space is bound by the uncertainty principle. Energy cannot just sit perfectly at absolute zero. Because of this, the vacuum is constantly bubbling. Out of nowhere, pairs of virtual particles spontaneously pop into existence. An electron and its antimatter twin appear from literal emptiness, exist for a fraction of a trillionth of a second, collide with each other, and instantly vanish back into nothingness. This isn't just a wild theory. It's a proven fact of physics known as the Casimir Effect. The vacuum is not static. It is a boiling, churning sea of quantum fluctuations. The universe is borrowing energy from emptiness, creating matter and destroying it before the laws of physics can catch it. Empty space is alive. This brings us to the ultimate cliff. If a vacuum is full of fields and the quantum realm is boiling with virtual particles, then we have to ask, can absolute nothingness actually exist anywhere? Or is it just a figment of our imagination? Some physicists argue that absolute nothingness is physically impossible. They suggest that space, time, and the fundamental laws of physics are woven together so tightly that you cannot unpick them. You cannot have a place without space, and you cannot have space without energy. But other theorists suggest a different radical idea. What if before the Big Bang, there was a state of true absolute nothingness? No space, no time, no matter. And what if that absolute nothingness was so unstable that it violently fractured, causing a quantum fluctuation that birthed our entire universe? It means everything we see, everyone we love, and every star in the sky might just be a ripple inside a cosmic zero. You might wonder why some of the most brilliant minds on earth spend their entire lives chasing a ghost. Why does defining nothing matter so much? It matters because understanding the vacuum is the key to unlocking the deepest secrets of our existence. Right now, there is a giant gap in science. We have two incredibly successful theories: general relativity, which explains the big universe like gravity and galaxies, and quantum mechanics, which explains the tiny universe like atoms. But when we try to combine them to understand how the universe began, the math breaks down and gives us an answer of infinity. The bridge between the two theories is hidden inside the vacuum. If we can truly understand what space is made of when there is nothing else around, we will finally have a complete theory of everything. Despite all of our massive particle accelerators, space telescopes, and mathematical equations, science has hit a wall. We can measure the weight of an empty vacuum. We can calculate the exact speed at which virtual particles pop into existence. But we are still fundamentally blind to the ultimate baseline of reality. We do not know why the quantum fields exist in the first place. We do not know why the laws of physics are programmed the way they are. We can map the universe back to a fraction of a second after it started. But we cannot confidently peer behind the curtain of the Big Bang to see if true nothingness preceded it. Science is incredibly powerful, but it requires honesty. And the honest truth is, the closer we look at the empty void, the more questions we uncover. The boundary where physics ends and the unknown begins is painted in the color of emptiness. So, we return to where we started. What is nothing? Perhaps the beauty of the question is that it forces us to look at something with entirely new eyes. We can imagine a void, we can write equations for a vacuum. But true, absolute nothingness remains just out of reach, a cosmic secret that the universe guards with everything it has. In our desperate attempt to understand emptiness, we didn't find a barren wasteland. Instead, we discovered that the universe is staggeringly rich, creative, and active at every single level. In trying to define nothing, we accidentally learned everything about the beautiful, chaotic, and miraculous nature of reality. The mystery remains, and perhaps that is the greatest gift of all.